Welcome back, everybody. So, today we are going to be looking at the viral threat that is emerging in a very major way, okay, that is the hantavirus. So, in the previous video, we have given just an overview about hantavirus, about its transmission, diseases that it causes, and how can you prevent it, right? So, hantavirus is the new viral threat that has emerged and resurfaced in a major way. As of May 2026, a deadly cluster has been identified that is aboard a cruise ship in South Atlantic, with multiple cases that has been confirmed and deaths reported among the passengers who have been traveling from Argentina. So, but what exactly is hantaviruses? So, hantaviruses are RNA viruses. They are from the Hantaviridae family. So, they usually jump from rodents to humans. That's why they're called zoonotic pathogens or zoonotic viruses. So, why suddenly there is a spike in hantaviruses? So, scientists point to the environmental drivers like the climate change, which is driving the rodent migration, and the urban encroachment, which is bringing the humans into more frequent contact with these hidden pathogens. So today we are going to explore how we have managed this threat before and the new tools we are using to contain it now. So to stop an outbreak, you should first know how it moves. The primary danger is aerosolation. So when the rodent urine, saliva, or droppings are disturbed, perhaps during cleaning in a dusty cabin or a shed, microscopic viral particles, they become airborne. So breathing this silent dust is the most dangerous and also the most common way humans get infected. Okay. So this makes the confined spaces like cabins, farms, sheds, and even nautical vessels, they'll have high priority zones for exposure. So while the most strains they do not spread between people, the Andes virus, which is a specific strain of hantavirus, has been confirmed in the recent 2026 outbreak. And this is quite unique because it can spread through close human contact. This is the only hantavirus strain that is known to also spread from human to human through close contact. Okay, so that's why this is important. So this shifts the containment game from managing the rodents to active contact tracing of the entire travel networks. Okay. So many ask, have this been contained before? And the answer is yes, but not in the way you might think. So look at the timeline of the 1993 Four Corners outbreak, which happened in the US. Okay, so within just months of the first mystery respiratory cases, public health officials they had identified the specific rodent that is responsible for that, like the deer mouse, has the reservoir or the vector. Okay, so they did not eradicate the virus; they contained the outbreak through rapid behavioral change. So they educated the people about safe cleaning and proofing. So they broke that chain of transmission. So it's a master class in how vector mapping and community awareness can stop a killer in its tracks. So hantavirus containment is quite unique compared to Ebola virus or the COVID-19. While those often require human lockdowns, hantavirus containment focuses heavily on structural containment and not people. So you have to like sealing the buildings, proper ventilation, and disinfecting the environments, okay, through bleaching are the ways that so the structures are the where how the quarantine and containment is done, okay, in the case of hantavirus. But however, with the case of Andes strain, the ability to spread between people, modern responders are now using hybrid strategies. So today in 2026, we have a new technology edge, that is AI driven surveillance. So by analyzing the rainfall patterns and seed drop data that can lead to rodent booms, health agencies now can predict the outbreaks before the first human has been ever infected. Okay, so this is a transition from reactive medicine to proactive environmental engineering. So to understand why we treat hantavirus containment so differently, we have to look at the blueprint, which is compared to the other major threats. So you see the structural profile. So unlike the filamentous Ebola virus or the spiked SARS-CoV-2, the hantavirus is an enveloped spherical pathogen that is from the Hentaviridae family. Okay, the genome complexity, so it has a unique three-segmented single-stranded RNA genome, which is very different from the single-segmented genomes of Ebola or COVID-19. Coming on to the transmission, while viruses like the Lassa fever and the Ebola often focuses on direct contact through the bodily fluids, hantavirus is more like the plague bacterium. It is more heavily tied to a rodent vector. Containment. So because the hantavirus is transmitted through rodent, urine, droppings, or aerosol, so rather than primarily through human respiratory droplets, so our containment playbook shifts from social distancing to environmental engineering and rigorous vector control. So understanding these structural differences is exactly how you can determine if you need a vaccine, a lockdown, or simply a better sealed building. So how do you go forward? We are outsmarting the virus through vigilance. So the action plan is quite clear. Okay, seal the structural gaps and keep the rodents out. And if you're cleaning a potentially infested area, never dry sweep or vacuum the area. Okay, when you're cleaning, use some kind of safe disinfection, like use a 10% bleach solution to wet down the surfaces first. So early diagnosis is very important here. Getting help within 48 hours can be life-saving because the HPS, that's the hantavirus pulmonary syndrome, can progress to respiratory failure rapidly. So we do not beat the hantavirus through isolation. We outsmart it by staying informed and respecting the boundaries between our world and the wild. So stay safe and thanks for watching.